Let's take a look at the next problem. This is question number 15. Now we're working with a compound inequality, which has three pieces, and whatever you do to one piece, you have to do to all three pieces. Our variable x is in the middle, so that's where our attention goes. To get the x by itself, I would need to get rid of this positive 6. So I'm going to subtract 6 from all three pieces. Negative 6 minus 6 is negative 12, is less than or equal to 3x, is less than positive 3. I have one more step to get the x by itself. I need to divide every single piece by positive 3. And I get negative 4 is less than or equal to x is less than 1. That's my solved inequality. If I go to graph this, notice that I have two numbers to plot this time. I have the negative 4, which is somewhere here, and I also have the positive 1. The negative 4, because x is greater than or equal to negative 4, that one would be included, and because x is less than 1, the 1 would not be included. And we see how our x is kind of sandwiched in between those two numbers, so you would be shading the area of the line that's in between those two. So our final answer in interval notation, this would be the interval from negative 4 to positive 1. The negative 4 would be included, the positive 1 would not be. Let's take a look at part B. We want to try and solve this for the variable x. A couple different ways you could approach this. You could go about distributing the 9 through, or if you notice that the 9 is a multiplication factor, you could actually start by dividing every single piece by 9. We would get negative 2 is less than or equal to, these cancel, x minus 5, which would be less than or equal to positive 3. One last step to get x by itself, we need to get rid of a subtraction by 5. So I'm going to add 5 to all three pieces. This would say that 3 is less than or equal to x is less than or equal to 8. So we have our solved inequality. Let's go ahead and graph this on a number line. We have two values, 3 and negative 8. 3 is here, 8 would be somewhere to the right of it. We see that our x is sandwiched in between, so we're going to be shading the part that's in between those two numbers. The 3 is going to be included because it's a less than or equal to symbol. And similarly, the 8 will also be included because it's a less than or equal to symbol there. So our final answer in interval notation would be from 3 included up to positive 8 also included. And there's your three different methods of solving an inequality. You have the solved inequality, we have the graphed interval, and then we also have the interval notation. Let's go ahead and take a look at number 16. Now we're kind of getting into exponents. We have a quantity being raised to the fourth power. Before we can do anything here, let's actually simplify what's on the inside. We have a bunch of powers of x we can work on. Whenever you multiply by like bases, you're supposed to add the exponents. X to the fifth times x to the third times x, which is the same thing as x to the first, would be x to the ninth power. That's 5 plus 3 plus 1. For the next step, we're raising a product to a power. So we need to make sure that we raise every term on the inside to that fourth power. So it's going to be negative 3 to the fourth. And we also need to raise the x to the ninth to the fourth power. Negative 3 to the fourth means negative 3 times negative 3 times negative 3 times negative 3. That'll end up being a positive 81. And then when you have x to the ninth to the fourth, that's a power to a power. Whenever you raise a power to a power, you multiply the exponents. So it'll be x to the 36th. Let's take a look at the next one. In question number 17, they ask us to simplify. We have 40x to the negative fourth times y to the negative sixth, all divided by 12x squared times y to the third. Let's kind of work with the coefficients first. If I look at the 40 and 12, I know both of them share a common factor of 4. So I can divide both top and bottom numbers by 4. 4 will go into 40 10 times. 4 will go into 12 3 times. So I'm going to have a coefficient of 10 up top and 3 on the bottom. If I look at my x's, I have x to the negative fourth in the numerator, and I have x to the second in the denominator. There's a couple of different equivalent ways you can think about this, but generally speaking, whichever piece had the most amount of x's is where the x's will end up in your final expression. Because I had more x's in the denominator, that's where my x's will stay. So you can do kind of like a directional subtraction. I have x squared minus a negative 4x. Or another way to think of it is if these x's are in the numerator with a negative exponent, you can bring them down into the denominator as a positive power of 4. Similarly, if you look at the power of y in the numerator, you have y with a negative exponent up top. That means you can take a reciprocal, move those y's to the 6's down into the denominator, and now they become a y to the positive 6th. All of our variables now have positive exponents, and so this is a very easy and convenient place to go ahead and combine them. In the denominator, you have x squared and another x to the fourth. When you multiply by like bases, you add the exponents. That should give us an x to the 6th. And then I have y cubed times y to the 6th. That would give us y to the 9th. A more literal and direct way of kind of working out something like this, by the way, if you had x to the negative 4th divided by x squared, you could just use the property that this would be 1 divided by x squared minus a negative 4. Just be very careful with your signs here. And that's yet another way to see that you would have an x to the 6th in the denominator. Take a look at number 18. We want to simplify this. Again, we should probably work on order of operations first. Let's do what's in the parentheses. 3 can go into 15 5 times. I had 3 powers of c in the denominator. Those will cancel with 3 powers of c in the numerator. So I'm going to be left with a c squared. Again, that's just 5 minus 3, which would be c to the second. Here I have d to the 6th divided by d to the negative second. That would be d to the 6 minus a negative 2, which would be 6 plus 2, which would be 8. Whole thing raised to the negative second. I now need to raise this product to the negative second power, which means I need to raise each term to the negative second. So I'm going to have 5 to the negative second. C to the second raised to the negative second. That's a power to a power, so I'm going to multiply those. That should be c to the negative 4th. And similarly, d to the 8th raised to the negative second should be d to the negative 16th. I have a bunch of negative exponents, so let me take reciprocals to make those positive. This is going to become 1 over 5 now to the positive second, c to the 4th, d to the 16th, which is the same thing as 1 over 5 squared is 25, c to the 4th, d to the 16th power. Let's take a look at part B. Again, try to simplify and do what's in the inside first. I know 50 can divide into negative 100 negative 2 times. I have an x to the 2 minus negative 2 will give me an x to the 4th in the numerator. And then in the denominator, I have y to the 10th. And I'm going to subtract a negative 5. That'll give me a y to the 15th in the denominator. Okay, if you don't like thinking of it like that, you can imagine these x to the negative seconds as coming into the numerator as an x to the positive second. And then you have x squared and x squared up top, which would make x to the 4th. Similarly, if you wanted to take these y to the negative 5ths and move them into the denominators, y to the positive 5th, then what you would see is you'd have y to the 10th times y to the 5th in the denominator, and that's also going to give you that y to the 15th power. So a couple of different equivalent ways of thinking of it, of how you can simplify the inside part. Once we're here, we now need to raise each term on the inside to the 4th power. So I'm going to have negative 2 to the 4th. We're going to have x to the 4th to the 4th. That's a power to a power, so I need to multiply the exponents. Similarly, in the denominator, I have y to the 15th to the 4th. Power to a power, I need to multiply. That should give us 60. And then we can just work out the negative 2 to the 4th. That should be a positive 16. So we get 16 x to the 16th divided by y to the 60th.